Hayalperestlerin, risk alanların, denemekten korkmayanların cesaretinden doğduk. Bizi asla yarı yolda bırakmayan o sesin rehberliğiyle ilerlemeye ve öğrenmeye devam ediyoruz. Bunun için varız. Bu yüzden gece geç saatlere kadar lambalarımız sönmez. Elveda demek hem hüzün hem de gurur verir. Her şeyi sorgulayarak ve merakımızı besleyerek, dayanıklılığımızı test ederek, sınırlarımızı aşarak, ilerleyerek ve yeni ufuklar açarak yeni bir yol buluruz. Yeni icatlar çıkararak, kendi yolumuzu çizerek. Burası fikirlerin doğduğu ve yeni fikirleri doğurduğu, bizim de doğduğumuz, birlikte büyüdüğümüz ve yükseldiğimiz yer. Burası Yakın Doğu Üniversitesi.
Hello everyone, and welcome to our Room 1, Session 1. I would like to start this session by welcoming everyone. Welcome everybody. Welcome to our third International Conference of Water Programs in Mediterranean countries and our sixth International Conference on Natural Resources and Sustainable Environmental Management. So let us start with our first presenter, which will be Dr. Gianni Huang, whose paper is titled How to Increase the Resilience of a City by Integrated Water Resources. Welcome again, everybody. Enjoy the video.
Hello, everyone. I'm Professor Jinghui Huang from Nankai University, China. I'm also the General Director of Sino-Canada Joint R&D Center for Water and Environmental Safety. It's my great honor to be invited to join the webinar with the theme of Smart City and Sustainable Water Resources Management Strategies. Today, I'd like to talk about under the changing environment, including climate change and rapid urban development. How can we increase the resilience of city by integrated water resources management? I'm going to give the talk in 4 aspects. First, extreme events induced by climate change. The second, the impact of urbanization. The third, integrated water resources management. And then the conclusions. The first part, extreme events induced by climate change. Climate change is now not a question anymore. The Earth became warmer and warmer. This is not only from the projection, but also from our own experience recently. Give an example how the heatwave events would have the huge impacts on human beings' health. In the summer of 2021, extreme heatwave events in Western North America occurred. It can see in the picture the temperature, some part has rose to 50 degrees Celsius. In Vancouver, on the first day of heat wave event, the temperature rose to 37.2 degrees Celsius. Based on investigation report published in 2022, there are more than 600 people killed directly related with the heat wave events. The heat wave event actually is not an isolated event. We can see in just about half month later, what happened in the other side of the world, Zhengzhou in China. The rainfall amount on July 20 in the afternoon, in just 1 hour, reached 201.9 millimeter. It is equivalent to 1/3 of the annual precipitation in 2020. It was also the largest hourly rainfall intensity ever recorded in the world. Heavy rain continued to pour into various subway stations. Ground transportation was completely shut down, and the city was severely flooded. Just a few days later, huge flooding also occurred in United Arab Emirates. 7 people confirmed died. This was the country's heaviest rainfall recorded in 27 years. The above indicate we are living in a changing environment. The risk of extreme events occurs more frequent than before. The climate change is affecting every corner of our world. And how about urbanization? In fact, the urbanization also have a huge impact on precipitation. I'm going to show a case study we did recently. We're now experiencing the most rampant urbanization around the world. By the year of 2050, more than 6.3 billion people are expected to living in urban area. Urbanization brought a huge modification of land surface. It changed the heat capacity, albedo, and the roughness in the urban land surface, and also affect the near-surface climate by changing the energy and the water balance. So the urbanization affect the regional rainfall characteristics and also potentially lead to increased extreme weather events. Recently, we did a study for Beijing. We studied how the urbanization has the impact on the local rainfall. This figure shows the geographic features of Beijing. Here, this mountain, and here this is the plain area, and this is the layout of transportation. Here this is the 4th ring, 5th ring, and 6th ring of the road. And here is the gauge station we used for this study. And from this figure, it shows the change of imperviousness. So we found there's a changing point on the year of 1998. So before 1998, there's a very slow growth of imperviousness. However, after 1998, the imperviousness grew very fast. So we divided the data into 2 sides. One is called the slow development period, and the one is called the fast development period. We first studied the spatial characteristics of heavy rain. That's the spatial distribution of the total days of heavy rain. You can see before 1998, the center of total days is in the northeastern area. And after 1998, the center of the total days of heavy rain moved downward to the southwestern area. And the same thing happened for the rainfall intensity. before 1998, the center of the rainfall intensity is on the northeastern part of the urban area. After 1998, it's also moving downward to the southwestern area. We also studied hydrological homogeneous regions. For the homogeneous region, it means this gauge stations has the similar statistic characteristics. So from this picture, we can see during the slow urbanization period before 1998, we have two hydrological homogeneous regions. One is in the plain area, one is in the mountain area. However, during the rapid urbanization period, we found there's another homogeneous region between the mountain area and the plain area. So from this table, you can see before 1998, the mean value of the this rainfall actually didn't change too much. However, the standard deviation, the third region is the highest, and also the skewness has the highest number, and the quartiles has the highest number. Let's look at the design rainfall. We did a comparison of IDF curves of 24-hour duration for return periods range from 2 to 50 years and show in this figure. This is the slow urbanization period, this is a rapid urbanization period. Let's only look at the 50 years return period. So for the region 1, we can see is over 100 millimeter. And for the region 2 is slightly above the 200 millimeter. However, after the rapid urbanization, what we can see for the region 1 is reach 150. And for region 2, the 50-year return period is about 240. And for region 3, the new regions we found during the rapid urbanization period is about 300 millimeter per hour. So for 24 hours. So this we can see very clear there's an upward shift in rainfall intensity for the same return period in the rapid urbanization period. We can see this might be the effect of climate change. However, the highest increase in region 3 than the extreme rainfall rise 87 millimeter for 24-hour durations at 50-year return period. Well, the other two regions only rise about 19 and 35 millimeter. This should be the effects of the synergy of climate change and urban development. It's well known in late July and early August, a huge storm hit in Beijing, caused a big flooding. So if you look at this area, there's between the mountain area, here is mountain, and here there's an urban development area. So the center of the rainfall, or the highest rainfall, fall in this area. And here, this the gauge of Mentogo is also located in this area. So the annual rainfall, this bar, and here this the recorded rainfall in 3 days. So you can see in just 3 days, 2/3 of the rainfall just recorded in this gauge. And in Hebei area, Hebei province, one gauge recorded the largest amount of rainfall is over 1 meter. So from this figure, we can see the spatial distribution of the rainfall follow the pattern we started in the rapid urban development stage. Yeah. In summary, we can see the formation of megacity or the rapid urban development has changed the temporal and the spatial distribution of extreme rainfall. In future, especially in megacity or urban clusters, the urban engineering design should consider the combined effect of climate change and urbanization on rainfall and the corresponding design standards in order to combine the flooding risk. So we have a question. Why does megacity development cause changes in the spatial and the temporal changes of extreme rainfall? What are the driving factors? Here we want to talk about the relationship between the urban heat island and the rain island. So from this figure, you can see the urban development, especially the rapid urban development, quickly changed the water surface. So that's the typical urban development. We have a lot of built-up area. So for the built-up area, because they can absorb a lot of heat from the sunshine in the daytime, so they accumulate a lot of energy here. And they also release slowly the energy in the night to the air. So they have the actual energy for storms to develop and intensify. In the contrast, in the parks and vegetated area, for example, the suburban area, they have more vegetation, more trees, so they typically have a cooler surface temperature. And also the water balance and the energy balance has been changed during the urban development. So that's why the city get hotter and the storm get intensified in the city. We still use Beijing as an example. So here, that's the impervious before and after 1998. That's the fourth ring, and that's the fifth ring, and here this line is the sixth ring. So from this figure, we can see within the fourth ring, the heat island, the urban heat island, didn't change too much. This before 1998, this after 1998. However, for fourth ring, the area between fourth ring and fifth ring, we can see there's a much bigger change between them. So before it's only 5.69, but right now it's raised to 6.81. So there's a big change in the urban heat island. And same thing happened between fifth ring and the sixth ring. You can see before 1998 is only 3.61, and after 1998 is 4.83. So there's more than 1 degree increase. There's the urban heat island show before 1998, and this urban heat island show after 1998. So from this figure, we can also see the increase. So what happened? It can be illustrated in this figure. So this suburban area, this suburban area. So because this area is hotter, so the air will go this way, and the air will go this way. So they have rising air in this area. So we have explained that's the actual energy accumulated here. The expanded urban heat island can trigger or reinforce the formation of the thunderstorm formation, and also tend to induce the strong convective activity. It inferred as a vital factor for higher frequency of heavy rainfall. We have published these results in Urban Climate 2001. I give the link here. So if you have more interest, you can refer to this published paper. Here is the special characteristics of heavy rainfall. During monsoon season in summer, for example, July and August, the wind usually come from this way. So here is the mountain. So from the topography, we can see the water vapor will accumulate in this area. Here, because the rapid urban development, they have a lot of energy, have the release from here, the heat energy. So when it meet with the cooler vapor in the air, then will form the rain, the heavy rain in this area. So and this also, the conclusion has been published in Urban Climate in 2021. In summary, we can see the huge modification of land surface by rapid urban development. They have changed the energy and the water balance, resulting in the change of the rainfall pattern. The urban rainfall island phenomenon is highly correlated with the urban heat island. So if we can mitigate urban heat island, then it can some way to elevating the urban rain island phenomena. Then we come to a question: what are the effective way to mitigate the heat island effect and rain island effect induced by urban development? How to optimize the ecological landscape patterns in urban to mitigate the heat island effect? In the third part, we want to talk about integrated water resources management. How the integrated water resources management would have the effect to mitigate the urban heat island and also urban rain island. In addition, how the integrated water resources management can contribute to the adaptation to climate change. First, we want to implement the guiding principle ADAPT. This the design principle ADAPT in British Columbia, Canada. So for ADAPT, first we need to agree that stormwater is a resource. Then we design for the complete spectrum of rainfall event. We action on a priority basis in at-risk drainage catchments, plan at 4 scales: regional, watershed, neighborhood, and site. And at the last, we need to test the solutions and reduce cost by adaptive management. LID, the low-impact development, has been proposed for several decades in Canada, in North America, in many places around the world. It's a natural-based solution using natural way to restore the hydrological cycle. For example, the evapotranspiration and infiltration. And also we want to install the post condition to pre-development condition, and this is distributed control. However, recently in China, we initiate the Sponge City implementation in 2015. So this integrated management for full spectrums of rains and from large scale to watershed and further to regional scale. So this actually is a big wheel and has historical control of the entire system. An article published in Where in 2022, October 17, it says, if you don't already live in a sponge city, you will soon. So this paper explains what is sponge city. Less pavement and more green spaces help absorb the water instead of funneling it all away, a win-win for people and urban ecosystem. So what's the real meaning of a sponge city development? Let's explain it for the sponge city development in 4 basic principles. First, we need recognizing rainwater and the snowmelt as a valuable resource, so we need to provide more storage for them. The second, we need managing wide flow on a watershed basis. So it's not a scale basis, it's not a regional basis, but it's a watershed basis using an ecosystem approach. So we cannot only consider people, we also need to consider the entire ecosystem. The third, we need implementing in a hierarchical way of wide flow practices. So we need to start with at source, that's LID, the low impact development. Convenience, that can be green and the gray system. And then we use end of pipe. End of pipe, it could be green, it could be gray, it could be blue. So this integration of green infrastructure, gray infrastructure, and blue infrastructure. And also, we need to informing and educating communities about wide flow issues and involve the public in developing solutions. I also want to give a case study of Shenzhen. Right now, after 40 years development, it became a megacity with 17 million people living there. 40 years ago, it is a small village, like a fishing village, with only 5,000 population. So it's a very fast growing city in the world. First, I would like to use Guangming district as an example. Here, this is Shenzhen, where it's located, is along the coast area and also at the south end of China. And this is the map of entire Shenzhen. Guangming district is one of 9 districts in Shenzhen. So here, this is the land use in 2010. This is the land use in 2016, and this is the land use in 2020. The reason we use 2016 because in 2016, Guangming District became the national demonstration city for sponge city development. So starting from 2016, the entire urban development has to implement the guideline of a sponge city. So here you can see there's the land use change over years from 2010 to 2016 and to 2020. And also here, there's the vegetation surface, impervious, and the water surface, how it changed. The orange line indicate the changing in Guangming district So you can see all the vegetation surface is declined and impervious surface is increased. However, the water surface of the Guangming district first decreased, but later on increased. We did a comparison study of heatwave events occurred in Guangming district and the Shenzhen city over the past 40 years by using remote sensing data. From the data analysis, you can see this the results for Shenzhen and this the results for Guangming district. So in the past 40 years, Shenzhen has experienced 119 heatwave events. And Guangming district only experienced 27 heatwave events. And this figure shows very interesting results. In 1998, Shenzhen and the Guangming district, the time span of heatwave events is late June and mid of August. So about 2 months. And Guam district experienced about the same thing, but it's a little bit higher. So from late June to about September. However, you can see in 2020, after 40 years, Shenzhen actually the time span of heatwave events enlarged from April or May to October. So it's about 4 to 5 months. In Guangming district, we can see the time span actually shrinked from July to mid of August, so only 1.5 months. And also, we take 2019 as an example. Shenzhen city has a record high of 8 heatwave events occurred in 2019. And for Guangming district, it only experienced 2 heatwave events. So from this study, we can see the sponge city development indeed helped the Guangming district to mitigate the heatwave events. In addition, because it mitigates the heatwave events, and it will result in the decrease of ring island events. So the sponge city development, in fact, has reduced the extreme of the rainfall, and also they switch the rainfall pattern in the future. 2020 is a year with a lot of extreme events occurred. In September 7th to 8th, extreme storms occurred in Shenzhen, Hong Kong, Macau Bay area. Shenzhen broke the city's records for 2 hours, 3 hours, 6 hours, 12 hours, 24, 48, and the 70-hour rainfall totals. And the Stanley Station of Hong Kong recorded a 24-hour rainfall total of 842 millimeters. This is the highest 24 rainfall recorded at a major city in China, probably also in the world. The Hong Kong Observatory reported a 1-hour rainfall total of 158.1 millimeters, breaking the strongest rainfall record for Hong Kong since 1884. So the extreme storm was a once-in-a-century event. In 2 days, the city went back to normal. So this actually demonstrated the significant role played by the substantial investment in infrastructure and the non-engineering measures in recent years, especially in relation to the local level of emergency management. Hong Kong and Shenzhen and also Guangzhou city. They have spent billion and a billion in the infrastructure development and also the emergency plan. So it real works. It real works in the during the extreme storms. They have the last death toll occurred in this extreme storm. Here we want to show some examples of public education of smart city in Shenzhen. You can see the education actually conducted in elementary school and also kindergarten. And this big screen also shows the smart city and also the flooding prevention plan. So people knows how to protect themselves during the flooding event and how the smart city will help in the flooding protection and also the other ecological effects of smart city. In conclusion, we want to see the climate change and the urbanization both together have significantly changed the characteristics of heavy rain spatially, and the homogeneous area have been changed. The heavy rainfall became more extreme after rapid urbanization. The urban development also significantly intensified the urban heat island. The design storm needs to be updated more frequently in order to combine the flooding induced by extreme events. Green infrastructure can effectively mitigate the heat island effect, reduce the frequency of heat waves, and improve the resilience of city to heat wave events and high temperatures. To increase the resilience of city, the integrated water resources management, including green, green, blue infrastructure, are all needed. Public education is also a must. Thank you very much for listening. Here is my contact information. If you have any question, please do not hesitate to contact me. Thank you and have a good day.
Sorry about this. Thank you very much for listening. Now I would like to call Dr. Eva Precious to present the paper titled Global Climate and its Effects on Natural and Human Life, Evaluation of Vulnerability and Contributes to Climate Change. Dr. Eva, please, if you can hear me, please open your microphone. Hello.
Can you hear me?
Yes. Can you please open your camera too?
Let me try to share my screen.
Possible. Okay, you can press present. You can see it down screen.
Can you see my screen?
Right now, no, we can't see your screen. Can you open your camera too, if possible?
Yeah, I'm having issues with the camera. I don't know why.
Okay, no problem then.
But can you hear me?
Yes, I can hear you very well.
Can you see my screen now?
No, I cannot actually. It's disappeared. If you can, you know how, press present, then share screen, then just select your slides. After the share screen, click window, then from window you can select the PowerPoint window.
Can you see the screen now?
Just 1 minute. Yes. Just a little bit. No, it disappeared again. Please follow what I will tell you now.
Okay.
Yes, now it's visible now. Yeah. It was visible. Just open the PowerPoint again.
What about now? Can you see the PowerPoint?
Yes, just play the PowerPoint. Put it in reading mode. It will be better.
Can you see it now?
Yes. Thank you.
All right. Thank you very much. Good afternoon, everyone. My name is Efe Precious. I'm from Operational Research Center in Healthcare, nearest university. I have two collaborators in this project, Dr. Bena Ozun and then Associate Professor Dr. Ozun Dilba Osahin. The topic of my presentation, the title, is Global Climate Change and its effect on nature and human life, evaluation of vulnerability and contributors to climate change. Climate change occur as a result of the consistent alterations of the normal atmospheric weather conditions that result in an imbalance of the Earth's climate caused by the radiations from chemical, biological, or natural resources, leading to an increased surface temperature that is capable of causing an intense threat to human life, plants, animals, and the planet ecosystem. The objective of this study is to alert the world about the dangers that are associated with climate change and the factors that are capable of causing climate change. A follow-up aim and objective of this study is to reveal the top 10 countries that have contributed the most to climate change through the emission of greenhouse gases and other factors, and these top 10 countries that are making this planet a risk zone for humans, plants, animals, and the environment. And then finally, we are also going to see the project is going to inform us about the countries that are most vulnerable to climate change in a ranking format. So the methodology that I employed in this study is called the Fuzzy-Promity methodology. It is an MCDM technique that have existed for decades. It was first introduced by Brans and Vinco in the year 1985, and then it was further developed by Brans. So the decision-making tool called Fuzzy-Promity would be used to rank the countries, the top 10 countries that are most vulnerable to climate change, and then the top 10 countries that contribute the most to climate change. So we'll be considering, in ranking the contributors to climate change, we'll be considering some criteria, because Fuzzy-Promity works with the principle of criteria and alternatives. So we'll be considering criteria such as greenhouse gas emissions, deforestation, waste, power plants, oil drilling, transport vehicles, and then fossil fuel. Then to evaluate the top 10 countries that are most vulnerable to climate change, we were able to get about 14 countries that have been severely affected by climate change, and we are going to and then we're able to employ this model to rank them from the most affected to the least affected, using parameters or criteria like fatality rate, drop per capital GPD, worth of damages, food insecurity, decreased standard of living, effect on people's health, immigration rates. So the Fuzzy-Promity model works with a linguistic scale, a linguistic Fuzzy scale. It is a scale that is used to classify or categorize criteria into a range. And for this study, the range that we have chosen, the Fuzzy scale, is from very high to very low. So it works with this principle that the criteria that is most important is being classified in a particular range in order to what to evaluate the different alternatives that are available. For this study, the decision makers have, through the aid of their professionality, have classified fatality rate, which is an important criteria and should be given preference, and they've given it a very high weight. Even drop per capita GPD, worth of damages, food insecurity. And this is because for us to know the countries that are most vulnerable to climate change, we must consider factors or criteria like fatality rate, drop per capita GPD, the worth of damages, and then the food insecurity, because these are preferential factors, or they are important criteria, to put it in another word. And then decrease in standard of living effect on people's health is another important class that we have classified these two criteria in. And then the last one is immigration rate. All right, with this we are able to use the visual Fusipromity program, and this is the data that we are able to impute in it. And I'm going to run over this data for a proper comprehension of what you are seeing here. So these are the 14 countries to your left, starting from Rwanda, Japan, Kenya, Bahamas, and then you could see the fatality, the criteria up there: fatality rate, drop per capita GPD, worth of damages, and all of that. So these are the parameters that will be used to evaluate the alternatives. The considered year for this particular data is from 2018 to 2019. All right. So we remember the flood that took place in Rwanda in 2019 that claimed about 88 lives. So if we put it here, it means that the fatality rate is important, and we have given it what maximum preference. And then if you also remember the Osaka earthquake that happened in Japan in 2018 and 2019, that is called the Jebi typhoon, that claimed about 1,282 lives. In order not to waste time on this place, these are the data. So we are putting this particular data and comparing it or evaluating it with the alternatives in this manner. So after we run the program, this is the result. We noticed that Mozambique is the most vulnerable country to climate change, and this is because of these criteria in the previous slide, where you see Mozambique with a death fatality rate of 600 from the cyclone Kenneth that happened in 2018, 2019, and then the drop per capita GPD to 13.0, and then the amount that was the amount of damages that we encountered, the decrease in standard living that is very high, the effect on people's health that is high, the food insecurity very high, the immigration rate very high. So due to these factors, Mozambique was ranked the number one most vulnerable country to climate change. And this is followed by India, and then Japan, and then Kenya, and then Bahamas, Zimbabwe, Malawi, Philippines, Madagascar, Germany, Rwanda, Fiji, and then the last one is Canada. And like I said earlier on, that I mentioned earlier on, all of this ranking is as a result of these factors that have been gathered and then that have been evaluated. So this is the Promity, this result you are seeing here in a diagrammatic format. This is what it looks like. So after we also rank the top 10 countries that contribute the most to climate change, and we discovered that China is the first number one country that contributes the most to climate change, followed by the United States, followed by India, Russia, Japan, Germany, Korea, Iran, Canada, Saudi Arabia. And this is because of the emission, the radiation, you know, the, from carbon dioxide to the greenhouse gases and all of that that have been emitted. So these are the countries that make this planet kind of unsafe for what? For human, for animals, and for plants, because China is the first country, the number one country in terms of ranking that contributes the most to climate change. In conclusion, this study has been able to demonstrate that fuzzy probability is an effective model or tool in decision making. When you are faced with uncertainty, you will be able to decide to make a certain decision when you have alternative and criteria, and you evaluate the alternative with the criteria using the fuzzy probability. So it is an effective model. Furthermore, this study also helped to alert the world on the dangers associated with climate change and the factors capable of causing climate change. This study also reveals the top 10 countries that contribute the most to climate change through the emission of greenhouse gases and other factors like carbon dioxide, deforestation, waste, oil drilling, power plants, transport, and vehicles, thereby making this planet a risk zone for humans, plants, animals, and the environment. Finally, this study will help to resolve the argument on which country is the most vulnerable to climate change through the help of the fuzzy probability technique. We have been able to circumvent the hurdles that are associated with the argument, and concluded from the evaluation as seen that Mozambique is the most vulnerable country to climate change based on the criteria that have been considered in this study. And then more countries, in order to advance this study or to modify this study, more countries, more criteria can be added to improve the study. Thank you very much. If you have any question, you can send to my email, faprecious.unakbojero@neu.edu.tro. Thank you very much.
Thank you very much, Efe, for this good presentation. Now I would like to call video for Dr. Andrei Romano to present the paper titled Marine Cargo Delivery Optimization for Mediterranean Region using ant-colony algorithm. Thank you.
Good afternoon to everyone. Welcome to the third International Conference of Water Problems in the Mediterranean Countries. My name is William Falano. I'm here to present the paper titled Regression-Based Analysis of Surface Long-Wave Downward Irradiance, Impact on Soil Moisture and Temperature. We're going to be discussing the goals, the introduction, the significance of study, the experimental setup, the experimental result, the key findings, and our conclusion. Now, the goal is to conduct a regression-based analysis to examine the relationship between surface long-wave downward irradiance, the soil moisture, and the temperature in the Mediterranean. So the importance of this study is to understand the Mediterranean region. And we all know that the Mediterranean region is characterized by hot summers and mild, wet winters. And this makes it particularly vulnerable to the effect of climate change, which understanding the dynamics of the Mediterranean climate is crucial for predicting and adapting these changes, which could help us, help us in areas like agriculture, water resources, and ecosystem, and also human health as well. There are three key variables that plays critical role in shaping the Mediterranean climate and its variability: surface long wave downward irradiance, the soil moisture, and the temperature. Now, the surface long wave downward irradiance is the amount of infrared radiation emitted by the atmosphere that is absorbed by the Earth's surface. So this is done when the sun shines. It is fundamental driver of the material climate. Also, the soil moisture is the amount of water stored in the soil at a particular time. Also, temperature is the primary indicator of climate change and plays a central role in regulating various climate processes in the Mediterranean. So rising temperature can lead to more intense heat waves and reduce snow melt and alter precipitation pattern. So we're going to go to the significance of study. So the significance of study really is far beyond just academic curiosity. It also helps us dive into the practical implications of the regions for the region in terms of agriculture, ecosystem, and also water resources. So these key areas are where understanding the region's climate dynamics helps us, understand how we can properly address these three particular areas. So the contribution of these effect of climate change is going to help as a critical indicator for global climate change, because by studying this particular region, it gives us an in-depth understanding of how climate change is affecting some sensitive regions, which have very unique ecosystems. So this will help us and give us the knowledge to be able to provide valuable insight to global climate changes and how to model and adapt strategies to be able to mitigate these particular changes. So brief explanation of the data set. So the data set was gotten from data access viewer provided by NASA Power. This tool is valuable for resource for accessing and analyzing data related to climate dynamics in the Mediterranean region and beyond. So the parameters that we used for this particular experiment, we use surface soil wetness, temperature at 2 meters, the dew frost point at 2 meters, the wet bulb temperature at 2 meters, the earth skin temperature, temperature at 2 meters range, temperature at 2 meters max, temperature at 2 meters mean, all sky surface long wave downward irradiance. So the preprocessing technique. So firstly, we need some sort of data cleaning. Data cleaning was performed to remove noise and irrelevant data. We did some data normalization by scaling all our data to the range of 0 to 1. We removed some outliers in the data, and also we did some filters to be able to clean up the data. We used 3 machine learning models, and our choice for these machine learning models are because they're all powerful regression algorithms. They have powerful regression algorithms that are able to model complex relationships between variables. And knowing from our data set, we were able to we got a data set from 2021 to 2023 within this range, and we trained 845 days on these 3 models, and then we test 250 days on these 3 models. Now we're going to see the results. So from our results, we clearly saw the MAE, MSE, and the R-squared. So the MAE measures the average absolute difference between the actual and predicted values, and which is called the mean absolute error. So we see that it's very low in this instance during the training process. Also, the mean square error, the MSE, is also similar to the MAE, but it involves squaring the difference between the actual and predicted values. And we can see from here, because squaring the difference gives more weight to a larger error, making it sensitive to the outliers. So looking at this, we saw that the error was very minimal. And the R-squared also, the R-squared measures the proportion of the variance in the dependent variable that is predictable from the independent variable. So from here, we can see that, and one thing we should know about the R square is that it ranges from 0 to 1. So where 0 indicates that the model does not explain any variability, and 1 indicates perfect prediction. So here, we saw that during the training process, everything was close to 1. We had 0.96 for candles. For XGB regressor, we have 0.99 XGB regressor. For random forest, we have 0.98, which were all close to 1 during the training. So it shows that these 3 machine learning models were able to learn from the patterns, they were able to learn from our data set. Also, during the test process, as earlier said, we trained 195 days between 2021 to 2023, and we tested 250 days. So we trained 845 days. We split it at that time to 2. We trained 845 days and tested 250 days. So one thing we saw from the mean, from our results, is from the mean absolute error, we discovered that it was way less. It was very less. After squaring it, very less as well for these 3 particular models. And also we looked at the R square, which is the measures the proportion of the variance in the dependent variable that is predictable from the independent variable. So we can see that everything is close to 1. As I said earlier, that it ranges from 0 to 1, where 0 means that the model didn't learn anything, and 1 means that the model made perfect prediction. So here we can see that everything was close to 1. We had 0.88, 0.87, and 0.8. So let's go to the sharp value analysis. So looking at getting more insight to how these models are able to predict. We're looking at cat ghosts, for example. In this particular case, cat ghosts were able to use some of those parameters to predict. So there are these parameters that use certain more features from compared to others. So that's why we see the low to the high. So majorly, cat ghost was able to use the temperature at 2-meter dew, temperature at 2 meters, temperature at 2 meters wet, temperature at 2 meter max. That's where it extracted most of the information that it used for the prediction. And the range goes like that downward. So we're going to look at the scatter plots for Calibut. During the training process, we saw that the actual values, the predicted values were all close to the actual values. They were all on the actual values and scattered around the actual values. Also, looking at the test, also the predicted values were all close to the actual values, and somewhere on the actual values, most of them were close to the actual values, which indicate that the model was able to learn and also able to predict. Let's look at our time series graph for CatBoost. We saw that the actual and the predicted, looking at it, during the prediction for the 250 days, it was able to predict closely, which means that it was able to predict. If you see the graph properly, you see the predicted values and the actual value. They were all close. They were all close to each other. They were close to each other, which means that the model was able to predict properly. So I'm going to go to the sharp value analysis for the XG boost. The XG boost, looking at it, how it's again, how the features is extracted for its prediction. We discovered that it used mostly of the temperature at 2 meters, the dew, then temperature at 2 meters max, temperature at 2 meters wet, temperature at 2 meters wet, and the value goes down like that. So what you use the most was high, and what you use less was low. So our scatter plot, one thing we discovered from XGB boost, it was that the model was able to learn perfectly, close to perfect. So if you see the training process, you see that all the plots were on most like most of the plots were on the actual values. So they were very close. And then during the testing, we saw that most of the plots were close to the actual value, which made the model prediction quite good. Let's also look at the XGB boost time series prediction for the remaining 250 days. We discovered that looking at it carefully, we discovered one thing, that it was the prediction and the actual were on point, like they were close. They were so close from the graph. So they were so close. So it shows that XG boost was able to predict from what it has been trained on properly, and which makes it a good model for analyzing this particular kind of data. Also, we go to random forest sharp value analysis. For random forest, if we want to look into how it was able to predict, we saw that it's used mostly from high to low. It's used mostly temperature at 2 meters dew, also temperature at 2 meters max, temperature at 2 meters wet, and temperature at 2 meters as well. And looking at the scatter plot, we saw from the training that the predicted values were close to the actual, as well as the testing also the predicted values are close to the actual. Well, so from time series plot, what do we understand? We understand that the prediction and the actual were so close. For the 250 days, the prediction and the actual were very close. So what was our key finding in this particular experiment? We discovered that all these models seem to perform relatively well, as indicated by the low value of the mean square error, the low value of the mean absolute error, and mean square error. So the R square value indicates the proportion of the variance, as earlier said, in the dependent variable that is predicted from the independent variable. So the higher R values are generally desired, and all the three models have relatively high R value, with CAD boost having highest 0.8821. So you can see clearly that our R square, which is also known as the accuracy, was very close to 1, which you can say that the highest was 88%, which was CAD boost. So looking at what influenced the performance of the prediction, what are the factors that influenced it? We discovered that there was more importance on dew, frost point, the wet bulb temperature, the maximum temperature, which suggested that the variation in these methodological parameters significantly contributes to explaining the variability in the surface long way downward irradiance. And also the temperature-related impact. So the emphasis on temperature-related features indicated temperature conditions, including humidity, dew frost point, and wet bulb temperature, and the maximum temperature, which are key drivers affecting the downward long-wave radiation at the Earth's surface in the Mediterranean during this specific period of time. Also, the time series prediction. We discovered that a close alignment between the actual and the predicted values of three models indicated that the regression model is effectively capturing the patterns and the variations in the surface long wave downward irradiance. So this is a positive outcome and suggests that the model learned and is able to generalize well from the training data. So we concluded that the regression-based analysis shows the model was highly accurate, predicting surface long wave downward irradiance in the Mediterranean, yields valuable insight into the relationship with meteorological data variables, and this identify influential features, including the dew frost point, the wet bulb temperature, and the maximum temperature, which underscores the substantial impact of temperature-related dynamics on the surface long wave downward irradiance. Thank you for listening to my presentation. Thank you, everyone.
Thank you very much. Now I would like to call our last speaker, which will be Dr. William Falana, which will be going to presenting the paper titled Regression-Based Analysis of Surface Long Wave Downward. Thank you for listening.
To present you the research on maritime cargo delivery optimization for Mediterranean region using ant colony algorithm. A significant part of the world's cargo transportation is carried out by water transport. Therefore, optimizing fleet management is an important factor in reducing transportation costs and environmental pollution. We consider an algorithm to optimize feeder fleet operations to minimize the sum of tourist lengths of feeders, which allows us to reduce transportation costs and environmental pollution. As the Mediterranean region sea and basin have high intensity of maritime operations, such research is important and relevant. The goal was to define optimal values of input parameters of the ant colony algorithm in order to optimize the performance of the algorithm. Also to describe and implement an early stop parameter into the algorithm. The next tasks were defined in order to achieve the goal. To formalize variables used into the ant colony algorithm for a maritime cargo delivery model, to implement an early stop parameter into the algorithm, to show the advantage of the algorithm using the early stop parameter compared to the algorithm with a static number of iterations, to analyze the practical applicability of the research and suggested improvement in the algorithm, and to make a conclusion on the contribution to the field of the ant colony algorithm in particular to optimize maritime cargo delivery, an outlook of how the research should be extended and advanced. The following variables are used in a simplified maritime cargo delivery model, where n is a number of ports, m max is a number of feeders available to complete the delivery. Every feeder starts its tour of port 1 and ends up by returning to that port. The port is called the hub. The sum of these tours is the length of the shortest route to deliver maritime cargo and return to the hub. For simplicity, we assume this length to be equivalent to the delivery costs. We adopted the ant colony algorithm to solve the multiple traveling salesman problem for a maritime cargo delivery. This algorithm is based on the ability of real ants to find the shortest path between food sources and their nests. Once a single ant finds food, it returns to the nest, depositing pheromone on its way. The other ants can use deposited pheromone as a navigator. The more the pheromone is on ant's way, the higher the probability that ant will follow the pheromone. Because it takes less time for ants to find food and carry them back to the nest through the shortest path, after some time, more ants will choose this shortest path and deposit pheromone on it. Pheromone on longer paths evaporates faster than on shorter paths. And in the ant colony, algorithms are called artificial ants. They were also given a few new capabilities that do not have real ants. Artificial ants can determine the distance between ports, heuristic information, and they have a taboo list, a list of already visited ports, so ants can't revisit ports during its tour. Pheromone information and heuristic information are very important variables in the algorithm. If pheromone information is equal to 0, then the ant will choose only the closest available port. This corresponds to a classical nearest neighbor search. If heuristic information is equal to 0, only the pheromone trail is used for the selection. In this case, early convergence of the algorithm appears. Ants will build a pseudo-optimal route. So the right balance between pheromone information and heuristic information should be defined. Efficient heuristic algorithms are considered to find the most optimal solution using the least amount of time and computational resources. In solving NP-hard problems, such algorithms find solutions by making repetitions of calculations in a loop. In case of the algorithm with an undetermined number of iterations, the computation will continue until required result is not achieved. Such computation can be quite consuming, while efficient heuristic algorithms are well known for the capability to find an approximately optimal solution in a short time. A mechanism that can control the process of algorithm execution can solve the issue with time-consuming computations. we propose to use an early stop parameter as the controlling mechanism in the end colony algorithm for maritime cargo delivery routing. The early stop parameter denotes the allowable number of iterations of the algorithm without improving the execution result, the tours of feeders in our case. At each iteration, the best tour are compared to the current ones. In the case of a specified number of iteration in early stop parameter has passed without updating the best tour, the algorithm stops and results and returns the current best tour found so far. Otherwise, at least one of the best tours will be updated and counter of the past iterations will be reset. In the scope of the testing, the following parameters were investigated: evaporation parameter, pheromone information, heuristic information, and early stop parameter. All tests were performed for 5 to 50 ports. Such interval of ports was selected in order to investigate the influence of input parameters for a different amount of ports. The increase of evaporation parameter leads to the elongation of the route. Based on the results obtained in the experiment, the value of the evaporation parameter closer to 0.01 most likely would be the most rational. The higher the evaporation parameter value, the faster the pheromone trail disappears, which does not allow the ants to use the experience gained in previous iterations. To test the pheromone and heuristic information, the same approach was used. From this chart, we can see the instances where the value of pheromone information is greater than the value of the heuristic information have shorter routes. In addition, the following statement can be formulated. The ant colony algorithm finds better solution when the pheromone information value is greater than heuristic information value, because pheromone information trail has a bigger influence on the route planning. The final experiment was performed in order to investigate how the early stop parameter could be implemented into the ant colony algorithm and how it could influence the performance of the algorithm. During experiments, the number of iterations were overestimated in order to track at what stage the algorithm will stop producing new, shorter solutions. As the number of ports increases, the value of recommended early stop parameter also grows. Overall, we consider 10 multiple n, where n is the number of ports, as the recommended value of the early stop parameter. There's an option to launch both algorithm with and without early stop parameter. It depends on your needs. If there is no time limit, then you should go without early stop parameter. But if the speed is important, then early stop should be used. In the scope of the research, we have analyzed the ant colony algorithm for route planning in maritime cargo delivery. In particular, such input parameters of the ant colony algorithm as the evaporation parameter, pheromone information, and heuristic information have been studied. We also described an implementation of the ant colony controlling tool, early stop parameter. Depending on the value of each parameter, the algorithm performance changes. For maritime transportation of Mediterranean region, which continues to actively develop, these findings will allow to improve tours planning. An increase in the tour length leads to significant financial costs and increased level of environmental pollution. The longer the route, the more fuel, more frequent maintenance is needed. Another part of the study has been dedicated to the performance improvement of the algorithm. An early stop parameter is a tool which can be used in the ant colony algorithm in order to enhance control of the performance, execution time, and accuracy. It becomes possible not to limit the algorithm to a fixed number of iterations, but to use the early stop parameter to proceed with computations until the route improves. Also, a deliberately reduced value of this parameter can be specified in order to find approximately optimal tours faster, while the accuracy is a little sacrificed. This adds flexibility and control over the operation of the route search algorithm. Thank you for your attention.
Thank you very much. Now I would like to end this session. Thank you very much for your presentation. This is the ending of session 1. See you in session 2 after 15 minutes. Thank you.
Hayat hızla akıyor ve biz bu hızı seviyoruz. Her güne heyecanla başlıyor, her anı doya doya yaşıyoruz. İlk günkü heyecanımızla yılları aşıyoruz. Zaman akarken biz de kendimizi arıyoruz. Heyecanla, merakla. Sen de kendini mi arıyorsun? O zaman zamana yetiş. Bu sadece kendini bulmakla ilgili değil. Asıl heyecan kendini yaratmakta. Bir şeyler mi yaratmak istiyorsun? Mükemmel. Metali işlemeyi, bir bina yapmayı, bir iş kurmayı, hatta bir şehir kurmayı öğren. Hayat kurtarmak, teknoloji geliştirmek, üretmek. Hepsi burada. Ve burada tüm deneyimler profesyonellerle yan yana. Ancak hızlı ilerlemeliyiz. Çünkü bugün şimdi gerçekleşiyor ve yarın çok yakın. Hayatta öne geçmek istiyorsan önce zamanın önüne geçeceksin. Hep ileri gideceksin. Bu Doktor Suat İrfan Günsel. Tanıyor musun? Onun da söylediği gibi. Üniversiteler toplumların dokuma tezgahıdır. Toplumları geliştirir, dönüştürür ve gelişmesini sağlar. O burayı bugünden yarına hazırlamak için kurdu. Senin için, ileriye gitmek için. Yana ya da geriye değil. Sadece ileri. Çünkü gelecek çok yakın. Hadi harekete geç. Fikirlerin ne kadar ileride olursa yarına o kadar yaklaşırsın. Yanındakileri de geleceğe taşırsın. Bu senin geleceğin, senin fırsatın şimdi. Hadi yarını yakın. Hepimizi ileriye götür.